Today, we're going to make an Excel sheet that we'll use a couple times on how to sort of analyze standards. This is how I normally do it. So here's what I would do. So I'm going to start by just putting in some information for when you do an analysis. So say we did an analysis today, then I put some name my experiment, and I'm going to call it phosphate analysis. I would say the analyte, PO phosphate. PO4, maybe I'll call it phosphate analysis. I'll probably do something like this. Hudson River samples. Then I put the operator who's doing it. That's going to be me. Right, in case someone else is doing the analyses. Make this a little bit bigger. Right, I'd now put some borders here to make it look nice. Maybe I would center these. Something like that. Maybe I like them right. I don't know. Something like that. And now, right, we'd have it. So I'm going to start by adding we're going to have our standards. Right, we're going to have our name. It's a little bigger. We're going to have our actual standard. This will be our X. And our Y will be our absorbance. Right, and then we're going to have standard 1. Let's see if this will fill in for us. Sometimes it will. Yep. We're going to have 6 standards. Right, I'm going to say our first standard was 0, 0.5, 1, 2, 5, 10. You're going to have different ones when you actually do this. And I'll say our absorbance are going to have some, I know I made up 0, 0.008, 0.011, 0.039, 0.109, 0.229. Right, and so now we could make this look a little bit nicer, do this, to maybe we'll underline these. Maybe we can make a thick bottom border on this one. That looks nice. And as I said, the first thing you're always going to do when you have standards is you're going to make your standard curve graph. So we're going to go insert, I'm going to insert a scatter. Right, that's a nice standard curve. But now let's make that look like a nice graph. I'm going to get rid of the title. Right, you should all know this by heart now. So let's go to our chart elements, axis title, primary, axis title, primary vertical. We're also going to add trend line, add a linear trend line. Right, I'm going to double click on that. I'm going to put in the equation. I add like a little box around my equation. Let me click on that again. Fill, border, solid line. That's looking all right. So I'm going to do, right, you know this. So this is, right, put absorbance on the Y. Let me get rid of this. This is going to be, our phosphate standards. I'm going to say they're in micromole. We did not label it here, so let's go standard. Make sure these are labeled. We know what our units are. Oh no, so this one, you want to change these units. You really want to go from 0 to negative. That looks better. Our graph is already starting to look better. I don't like, let's get rid of the grid lines. Right, let's put some ticks in there. Tick marks. Major, outside. Click over here, tick lines, major, outside. And then you know I like a border, solid line. Black, make this line, solid line. Let me see if it clicked for me. Black, let's see if it does it. Solid line, black. Let's see how our graph is looking. Let me close this since I have my, okay, oh, this one never went. So let's see if we can do that one again. Click on that. Yep, solid line, black. That's starting to look better. I don't like the border around the whole thing, so we have no line. We're going to close. Right, that's starting to look better. I'm going to make it square. Move this here. I'm going to now go home. I'm going to increase all the fonts. Click on the whole thing. make the whole thing 12. And I'm going to make the box a little bit smaller. Maybe make these points 11, a little bit smaller. These points a little bit smaller. I don't know why. Oh, that's good. So now that's a nice looking standard curve. Right, so you have it, you can print it, you can show it. Now we have our standard. But let's actually now, if we have unknowns, we need to do our calculations. We're going to make our constants. And so we're going to need to know. We're going to need to know our slope, m, right? We're going to need to know our intercept, b. We're going to know our r squared. Then we're going to actually then calculate psi x, and this way we can also get a detection limit. So we can do all this. And so even though it's written on the graph, I like to calculate it. This way it automatically updates. So now the slope, there's actually a function equals slope, right, known y's, comma, known x's, close. You can do intercept equals intercept, known y's, comma, known x's. Oh, I put an extra parentheses by accident. Then you can see they should be matching what's up on the graph. R squared, there's a function for RSQ, known y's, comma, comma, known x's. Right, same matches. Psi x equals steyx, known y's, comma, known x's. Then you should be able to remember that our detection limit's equal to 3.3 for 3 standard deviations times psi x divided by the, I always forget, so I'm going to look, it's divided by the slope. There we go, 0.67 for this one. So this is really nice. So I'm going to make this look nicer. I'm going to put borders all around here, make it like a thicker underline. Oh, that's looking nice. And now what's going to happen, you'll look in your lab notebook, you're going to have your unknowns. Right, this is what you were trying to calculate. So you have the name of your sample, you're going to have the absorbance, you'll get the concentration, this way it's going to be in micromolar from above, and then if you have multiple ones, you'll have your average concentration and your standard dev. Right, so now let's think about it. So you can imagine we were down to peer. So you have, oh, I forget what you call them. So we're going to go peer, far, sample 1. We have peer, far. This is actually, what I'm going to do, this is sample 1. Right, you did it once, and I can call it rep 1. So if we do it multiple times, I can make that a little bit bigger. Right, then you can imagine, I don't know what it's doing. Okay, let's go here. Right, you can imagine we did 3 reps on your first sample. Right, and then they had absorbance. So if you do something like this, it's like 0.07. Oh, wrong spot. Undo that. Remember, it's always Command Z to 0.07, 0.072, and 0.068. Right, then you can calculate the concentration. You have your standard curve, right? You have your slope and your intercept. So what you do, remember y equals mx plus b. You also know that x equals, right? You can just swap and solve for x. So it's going to equal, then we're going to do the absorbance minus the intercept divided by the slope. See if I have that right. Right, and that looks about right. So, right, 0.07, that would be somewhere up in here. 0.07, yep, and that should be about 3. And now you could, oh, if I'm going to drag this down, we need our correct dollar signs. So put in your dollar signs. Drag it down, and that is good. And so now you have your calculated concentration, your absorbance, you know your sample name. So let's now put some, let's put that make that nice borders, put this thick underline on here, a thick bottom border, and we're looking good. But see, if this was 3 reps, you're going to want the average. So you do equals average, right? Get the average. Then you're going to want the standard deviation equals standard dev. And you get the standard dev of these 3, right? And then if you're in the notebook, and I show that you always want to, now this is going to be to 0.08 because that's, you always go to the first digits. Now we're going to go up to our, right? And then we have it to the correct significant figures. So it's going to be 3.25 plus or minus 0.09. Now you can imagine I'm going to have 3 more samples. We're going to go peer, shore, sample 1, rep 1. Make this a little bit bigger so it looks nice. Let me drag this down, right? So we're going to have 3 samples. What I'd probably do in reality, I'd probably put these right up. I probably wouldn't put a space. I'm going to put them right next to each other. And since we're in a new sample, maybe what I would do is I would underline it, right? And now we know what they are. And now let's see if we can look at these absorbents. I collected these absorbents, 0.002, 0.001, and 0.003. And so now we can get the concentrations. Drag these down. Good. And then we're going to do our average and concentration standard dev. We have those. But now this got a little bit messed up, so let me get the border looking nice there. Right? And let me see if I can put these. Thick bottom border. So now we can keep going. So now we have these 3. But now, if you look quickly, our detection limit, our value is less than our detection limit. So we are in a bit of a pickle here. So what do? What you'd actually do to make this work much better is, this is actually non-detect. We call this non-detect. And what I do is I actually put in an if statement. So now we can do equals if. So you say, if this average is less than the detection limit, then you have to call it non-detect. And then else, you put in this average. Let's put this in. Let's see if this works. This is going to be a much better way to do it. Oh, I have an error. I'm going to go for this correction, right? And that worked. So if the average is less than the detection limit, so I'm going to put $signs on that detection limit since it's not moving. And see, it's non-detect. So we can see if this works. So if we put it up here, right, we still get 3.25. The next thing is we don't want a standard deviation with non-detect. So you do equals if, right? You want to do if this equals n dot d dot. We're just going to do nothing. Else, we're going to give it the standard dev of these 3 values. Then we need double parentheses. It should work. See, nothing happens because it was non-detect. I'm going to copy that equation up here, and it still works, right? Because it's above the detection limit. So that's how I would do this. And now if you look, this is going to be really nice. So let's say you put in different absorbances. Say this was really, the standard was 2, and it was 0.022, right? Oh, that's not a good, look at that standard curve. We have 2 bad points there, but look, it does it all. Now it updated to r squared. It already updated all of our values. So like, watch. So when I watch, I'm going to make this a 1. See, everything changes. Make this a 3, right? You see it changes, the graph changes, your standard curve changes, your values change. This is a great way to do it. So as soon as you update it, as soon as you put in your values, it is going to be good. So now that's how it looks. So you should be in great shape to do a standard curve, and then your data is in great, print it out for your notebook, ready for your lab report.